The Internet Protocol is the main set of rules that governs the exchange or transmission of data between devices on separate networks. It's got two main jobs, and for both of them, an easy comparison can be made to the mail system. So number one is addressing hosts. Imagine if everyone on Earth just came up with their own idea of how they should go about sending an item to someone. Ideas like putting the return address inside the box for better personal security, or sending out 6 of the same thing to everyone on a city block to ensure that at least one of them will reach the intended target, may be well-intentioned, but would create a ton of unnecessary overhead leading to inefficiency. The Internet Protocol dictates the header format of a datagram or packet similar to the label on a package, as well as the way the data payload is nested within it to improve efficiency. Number 2 is routing, or predicting and selecting the best possible path for data transmission across network boundaries. This function is mostly performed by routers, and it's the equivalent of your parcel, let's say it's heading from the west coast of the US to France, reaching a courier hub in Chicago, where the decision gets made to forward it to New York then Paris, instead of letting it make stopovers in Brisbane, New Delhi, Moscow, and Toronto along the way. Seems pretty straightforward, right? Well, actually, we've got a small problem at the moment. IPv4, the first non-experimental version of the Internet Protocol and a cornerstone of the Internet as we know it, has only received relatively minor revisions since its original development in the late 70s, when the digital lifestyle we enjoy today with all of these connected devices all around us was basically science fiction. So it has some limitations that IPv6 was designed to deal with. First up, IPv4 allows for only about 4 billion unique addresses, which might sound like a lot, but once you do the math, it's not enough for every device on Earth to have its own address, and without a unique address, there's no way to ensure that a packet is being delivered to the correct destination. IPv6 replaces IPv4's 32-bit address with a 128-bit address that allows about 340 trillion addresses. Enough for every person on Earth to have billions of addresses for every device they own. Well, hold on a second, Linus. 4 billion is already not enough. How did we make it this far? Great question. Aside from reusing IP addresses, one of the main ways we've alleviated the need to have more of them is through network address translation. This is kind of like apartment numbers. Two completely separate buildings can each have an apartment number 804, in much the same way that your PC at home can have the same 192.168.something.whatever private IP address as your PC at work, but their data never gets misdelivered. In the same way that those apartments have different public street addresses, all those overlapping private IPs are behind unique public IPs from which all the traffic appears to originate. Well, that sounds great, Linus. Why can't we just keep doing that? Once again, great question. NAT is not a bad thing, and you can keep using it with IPv6 if you want. It brings some real benefits to the table in terms of control and convenience if you were to switch IPs, for example, but security is a mixed bag, with its inherent firewall-like features considered good, but the fact that it messes with packet tampering prevention protocols like IPsec considered bad. And on top of that, NAT adds performance overhead and increases the complexity of peer-to-peer connections, which are great for file sharing, communication, and much, much more. Which leads into my next point, simplicity. Having each device be able to address every other device on the network will improve performance directly. And on top of that, with IPv6, devices can auto-configure themselves rather than relying on DHCP to get an address, and the header data that must be included with every packet, while actually larger to accommodate the longer addresses, has a ton of extraneous stuff that's been cut out to reduce overhead while allowing more customizability for the future. Sounds great, Linus, but just like we predicted that we'd need 64-bit processors to address more memory, we knew this was coming. So why didn't we switch 2, 5, or even 10 years ago? The answer is compatibility. Trying to access a website that only runs IPv6 from an IPv4 system just wouldn't work. There's no backwards compatibility built in. But that said, older hardware can sometimes be upgraded with new firmware for compatibility. Modern PC operating systems and even most phones out there have been IPv6 capable for some time now. So the issue actually isn't on our side, us consumers. No, It's the internet service providers holding us back once again. Moving to purely IPv6 equipment or dual-stack gear that can operate with both protocols is expensive, doesn't offer an easily communicated benefit to Joe Average customer, and most troubling of all, removes the need for carrier-grade NAT solutions that add overhead but also give your ISP a great deal of visibility and control over the traffic in and out. So why would they bother, given how fond the average ISP is of important stuff like maintaining net neutrality, which I would encourage you to read up on, because whether it seems important or not, the net neutrality debate will have a profound impact on the way internet communication works in the future, regardless of when we transition to IPv6. Speaking of reading up on things, not everyone has time to sit down with a book and catch up on their reading, and for those folks, there's Audible.com. Audible.com is the premier source for audiobooks online with a selection of over 150,000 titles. They've got dry stuff, like you just listened to for the last 6 minutes, and just kick back and enjoy an opposites attract love story stuff like 1+1 by Jojo Moyes. Nothing to do with the phone, by the way. The best part is that if you head over to audible.com/techquickie and try out their monthly membership, you can get a free, should put a fancy graphic, free with little sparkles, free audiobook right now just for signing up. Give it a shot. Thanks Audible for sponsoring this video. Thanks to all of you for watching. Like if you liked it, dislike it if you disliked it, leave a comment with a suggestion for future fast as possible videos, and as always, don't forget to subscribe if you haven't already.